Dear students, welcome to this tutorial about thermodynamics. The first law of thermodynamics, properly known as the law of energy conservation, when examined more rigorously, actually outlines the relationship between internal energy, work, and heat, which from now on will be represented by the letter Q. The law can be stated as an equation where delta U equal Q minus W. This means that the change in the internal energy of a system will be equal to energy transferred or from the system as heat minus the energy transferred to or from the system as work. And all these quantities will be measured in joules. Because of this law, we can outline a few different types of processes that can occur. If a process occurs where no change in volume for the system, that means that no pressure to volume work can be done and or by the system, so work is zero. In such case, the delta U equal to Q, and any change in internal energy must be result on heat transfer in or out. This will be called an isovolumetric process, meaning no change in volume. An example would be a bump calorimeter where a combustion reaction produces change in temperature but the rigid walls results in no change in volume. This is if there is no change in the temperature of the system, there cannot have been any change in the internal energy of the system, since these two values are proportional. Delta U will be zero, which makes Q equal to W. This means that any heat transfer into the system is used by the system to do work rather than increasing the internal energy of the system. This is called an isothermal process, meaning no change in temperature. An ideal version of car engines would be an example of this, as pistons out to convert all the heat energy from the combustion reaction directly into expansion work that moves the car. If there is no heat transfer, Q will be zero, and delta U will equal to negative work. This means that the internal energy of a system changes as a result of doing work on its surrounder or the surrounding doing works upon the system. Such process will be called an adiabatic process, meaning no heat transfer. We can see in this certain process in Earth atmospheres, as mass of air change position due to the pressure difference. And if Q and W are both zero, meaning there is no heat transfer and no work done, where can be no change in internal energy, and this must be an isolated system. Hopefully, these scenarios make some intuitive sense because we will frequently use this equation to calculation. We will also need to define the sign of this quantities in order to use these quantities properly. So let's note that when heat is absorbed by the system, Q will be positive. If heat is lost by the system, Q will be negative. As well, if work is done by the system, the work will be positive, and if the work is done on the system by surrounding like gas compression, the work will be negative. If there is no transfer on heat or no work done, this value can also equal to 0, as we'll have previously discussed. When doing calculation, make sure that you use the correct signs for these values or the mass will be incorrect. Thank you for your attention.